on number 1? The secant line, right? Cosine of pi over 3, what is the cosine of pi over 3?
What? 1/2.
1/2. What is the cosine of 0?
1.
So I get negative 1/2 on top. Divided by pi over 3. Flip and multiply. So times 3 over pi. Negative 3 over 2 pi over 2. Moving on to B. Not on that one. So it just asks what the derivative would equal. What f prime would equal. All of the following functions satisfy the conditions of the mean-value theorem on an interval negative 1 to 1 except what? What are the conditions of the mean-value theorem? Continuous and differentiable on the interval negative 1 to 1. Is sine continuous and differentiable? On any interval, yes. Sine inverse is defined from negative 1 to 1. So, yes, right? Because remember the range of sine is negative 1 to 1, so the domain of sine inverse is negative 1 to 1, and you do an inverse that's domain and range first, so that's good. X to the 5/3. What's the derivative, right? What's the derivative of x to the 5/3?
Like negative. No, the third.
Is that still defined everywhere?
Yes.
What's the derivative of that? Not. Why not? Negative exponent, which means that x is on the bottom, so it's not defined at 0. Is 0 between negative 1 and 1?
Yes.
Now, at first glance, how many of you think most people think E is not defined at 2, right? Why is that not a problem?
Not the choice.
2 is not between negative 1 and 1. So at first glance, seems like it's a good choice, but it turns out that D is not differentiable at 0. How many times does g of x satisfy the mean value theorem from A to B? Well, I'm going to draw my picture here. From A to B. I want to know how many times I hit that slope again. Would you agree somewhere in this area? No, but somewhere again in this area?
Why not? Why not at the bottom?
Oh wait, I missed one, you're right. Right there. And then, no, because I'm decreasing. And when I turn to increasing again. Okay, everyone agree? So how many? Doesn't ask me to justify, don't. If it doesn't ask you to justify, don't. Accidentally mess something up by saying something wrong. What conclusions can be drawn about g of x using Rolle's theorem? It tells us at the beginning that g of c equals g of d. So can we apply Rolle's theorem? Somewhere between c and d, g prime is 0. Any questions about those three? Limit question. Tomorrow we're going to do 10 limit question reviews. More practice. Start with this limit question. You have 2 options, don't you?
Yep.
Well, no, you don't. Okay. Maybe. What do you do first? No matter what. Substitute 5. What did you put in 5? 9. And then on bottom, 25 minus 5 is 20. Okay, over 0. What does it mean if you get 9 over 0? Vertical asymptote. So the limit does not exist. I think you're beating it to death on your AP packet. Am I correct? Had you sketch F prime and answer questions about it? We'll skip that one. But if you decide you want me to do it, I can do it. Okay, given a function, finding increasing and concave down. Find one where both increasing and concave down. I'm going to go through this fast. Again, this is just kind of some review to remind you how to do things. We're going to do the derivative and do a sign chart on the first derivative. So we are increasing from negative infinity to negative 4 and 3 to infinity. Everyone see how that would work. We would take the derivative factor so it equals 0. Then we would find the second derivative. Set it equal to 0 and do a sign chart for the second derivative. I want to know, and that gives you the inflection point for whatever reason we might want that. The question was, on what intervals is f of x both increasing and concave down? Well, I'm increasing on this interval and this interval, and I'm concave down on this interval, correct? So I need to know the overlap of that. This is at negative 1/2. Negative 4 comes before negative 1/2, so wouldn't it be negative infinity to negative 4? That would be where we would stop on that increasing and concave up. Function is continuous. By the way, this will be on headline. So you have to either go back and watch the video or go back and pull up the notes. Function is continuous from negative 2 to 4. F of negative 2 is 5, f of 4 is 1, and f prime and f double prime have the following properties. Find where all absolute extrema of f occur. So we want to find absolute extrema. I'm going to draw a quick sign chart. I have the information to do that. Does everyone agree? Because I have f prime information. That's some information about f. F prime we have, so from negative 2, that's where we start. We're going to 4. At 0, we have a critical point, and at 2, we have a critical point. We are increasing, decreasing, and then decreasing. Any questions so far? So let's talk about relative maximum. It could be at 0. I would say that's my only option for an absolute maximum. Why is that my only option for an absolute maximum? What about negative 2 and 4? Why are those not options for an absolute max? Because they are always sort of options. Right, it's increasing after negative 2 and then always decreasing. So there's no way that those could be absolute maximums. So the absolute maximum is at 0, no question about it. Those could be absolute minimums, though, couldn't they? So I don't know. One of them is the absolute minimum, either negative 2 or 4, and I don't know which one. Or do I? There's a reason they gave you that information at the top, right? Because the absolute minimum is either at negative 2 or at 4. There are no relative extremes, relative mins. 1 is lower than 5. So the absolute minimum is at 4. So absolute min's at 4, absolute max at 0. Find where the points of inflection occur. What derivative will we look at to find that? Second derivative. What do we look for on the second derivative? 0 does not exist, and changing signs. Does it change signs at 0? No, so that's not a point of inflection. But 2, does the second derivative change signs at 2? So So that is a point of inflection. Questions about that one? And sketch a possible graph of f. I'm increasing after -2, then decreasing, and then decreasing again. I am concave up from -2 to 0. Increasing. I am still concave up from 0 to 2, but I'm now decreasing. Do you now see why that first derivative does not exist? Makes sense, doesn't it? And then at 2, I switch to concave down, but still decreasing. Something like that. What I don't know is how high this point comes up here. Any questions about that one? What kind of question is this? Calculator or uncalculator? So, let g be the function given by that. When t is between 0 and 8, g is decreasing most rapidly when t is what? Any ideas? We could graph it and look. It might be hard to tell just by looking at the graph. Maybe not though, maybe that's it. I definitely would try it. What else could we do besides just looking and going, I think it's decreasing the most there?
First derivative.
Okay, and the first derivative would tell you when you're increasing or decreasing, correct? Let's just see what we're finding out. So I'm going to graph, get your calculators out. Remind you of some calculator skills you have. Your calculator will be slow when you do what I'm about to do. But okay. Make sure your calculator is in radians. Go to y equals, type the function in y1. If you don't mind, I'm going to move that so you can see the function.
Third hour.
Third hour? Yes. Yes. You're welcome. Make sure your calculator's in radians. Did I say that already?
Mhm.
I'm going to set my window, my x windows between 0 and 8. Does everyone know why I would do that? It tells me that that's where I told you to make sure your calculator was in radians. I did not put mine in radians. Where is radians?
Yeah,
Mode. If you graph that, this is what you see. Yeah, I don't know, right? Yours didn't work. Oh, window. Look at that. The constant there. What's the constant that's added to sine and cosine? So you probably need your y values to be, I did mine 0 to 250, which was a little too big, but sorry, I should have said that. Okay, now that's the function. Decreasing most rapidly, I don't know, maybe here or here I could at least make a good guess. Right. But I really would rather not guess. Right. So, let's graph the first derivative and see what that can tell me. I probably would have skipped straight to the first derivative if I had been doing this problem, but hey, it was good to see. But, save yourself some time. Go to alpha, window, inderiv, ddx, and type y1. Alpha trace is how you can get y1 at x equals x. And it will graph the derivative for you.
How do you get what one?
Alpha trace this derivative button, as you know, can find on screen, but we can trick it into graphing by writing x equals x, which is a little weird, but it works. At a specific point. So if you wanted the derivative at 3, there's been a couple that we did on our homework from that. Okay, I do need to change my window to see those negative values. Would you agree? Again, this is going to be a little slow. You could change your resolution to make it go a little faster. But now, what am I going to be looking for on the derivative? The derivative is whether it's increasing or decreasing, right? When is it decreasing? When it's below the x-axis. When is it decreasing the most? The minimum, right? The lowest point. So would we all agree that looks like it's over here? That one looks a little higher. I couldn't really tell that from the original graph, but I can tell now. And so now I can go to second trace, minimum. I do have to arrow down to the derivative curve. Now, if we wanted to do this by hand, by the way, which I don't want to, but if you wanted to do this by hand, you would have to find a second derivative and set it equal to 0, because you'd have to find the minimum of the derivative. So, 2 point something. 017B. So that was an interesting problem. I wanted to do it mainly to remind you what your calculator is capable of. Last one, and then we'll need to grade. Find values of c and d that make this function continuous. So this is a continuity question. What are we thinking to make this continuous?
See if they all can be.
How?
They're all like 3.
Plug 3 into what?
Each one.
The top one?
Oh,
The bottom 2. Everyone agree? Plug in 3 into the bottom 2. Why not the top one?
Because it's 3 is closer.
Yeah, okay. So 3 is too far away from the top one. Remember, a piecewise curve, those bottom 2 pieces are touching at x equals 3. So I want to know if they're equal at x. So I'll make them equal at x equals 3. So if I plug 3 at the bottom, I get 4. Everyone agree? So I know that 4 should equal 3c plus d. 1 at the top. -1 plus 3 is 2. 2 squared is 4. 0, 0. On the top. Which should mean what I get when I plug in -1 into the bottom. Or it's the middle one. And so now I have two equations, two things I don't know. I can use this as two equations. Would you agree C equals D? Add the C over C equals D. So use substitution. D is 1, which means C is 1. So that's how you would do a problem like that. So just today, I just wanted to do a little review of some limits and continuity and some mean value theorem. Make sure you memorize the mean value theorem and intermediate value theorem before Monday. You will need to know both of those. Any questions about this? All right, we're going to grade now your AP packet tomorrow.